Okay, now let's talk about problem number 23. How many triangles with positive area have all their vertices at points I, J in the coordinate plane, where I and J are integers between 1 and 5, inclusive? Okay, so we have a coordinate plane. We have from 1 to 5. So there are 2, 3, and 4. Same here. Oops, 5. And we want only I and J are integers. So this is where let me just draw out these points here. But it takes me too long time to do them properly. So basically it's just that we have this here. Yeah, much better. Okay, so the points has to be on the grid. 1, 2, 3, and 4. So the points has to be on the grid. I will now erase this coordinate because basically this question is asking us how many triangles can there be with the vertices of the triangles be a point on this grid. And the triangles has to have positive area. So we can have a triangle where like these 3 points, they have a line which can barely be called a triangle. So this is not allowed. Okay, so I mean, you can start with, if you don't know how to approach this, you can start giving yourself some examples and seeing like what 3 points satisfy being a triangle, what 3 points doesn't. But yeah, so soon you will find that most 3 points, like if you generate randomly select 3 points, most 9 out of 10, like a random number here, just most likely that they will be able to form a triangle. So I guess a reasonable way would be to calculate the total ways to select a random 3 points and then deduct the ways where they are on the same line, because that is the only case where they cannot form a triangle with positive area. So we calculate how many there are if we randomly select 3 points. How many points are there here? There are 1, 2, 3, 4, 5, 6. 6 times 1, 2, 3, 4, 5, 6. 6 times 6. There are actually in total. Wait, why are there 6 points? I think I may have drawn something wrong. So this is 1, 2, 3, 4, 5. Yes, I have drawn it wrong. There shouldn't be the 6th line. Sorry about that. And yeah, just to remind people to be careful when you are doing questions, check before you've gone too far on the wrong side. And yes. Okay, so now I have, there should be in total 25 points because that's what this question is about. Because I and J are between 1 and 5 inclusive. So yes, there should be 25 points in total. So if I randomly select 3 points, it should be 25 times 24 times 23 divided by 3 times 2 times 1. You can also write this as 25 choose 3 if you know this notation. If not, it's basically out of 25 points, you first select one, there's 25 choices. Then you have 24 choices to choose the second one. Then you have 23 choices to choose the third one. And if you choose A, B, C, and then you choose B, A, C, then they are essentially the same triangle, right? So any 3 points, there are 6 ways, which is 3 times 2 times 1 ways to select them. So yeah, this is 2,300. These are how many ways in total we can select 3 points. Now we need to deduct the cases where they are in a line. So how can they be in a line? Well, firstly and most obviously, they can be in a same vertical or horizontal line, like these 3 points or like these 3 points. They're just in the same horizontal or vertical line. So for each line here, like for each line here, there are 5 points. So there are 5 times 4 times 3 divided by 3 times 2 times 1. We can also write this thing as 5 choose 3. So this is the number of ways you can choose 3 points out of a single line and how many lines are there. there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember the horizontal and vertical lines. So times 10. This gives us 100. This is the first case. The second case would be, okay, so now we've figured out all the ones like this side. What about if I incline this line a little? If I incline it a little bit, then the next point that it can be is here, right? Well, here we don't have 3 points, but here we would have 3 points. Similarly, here, let me make it more accurate. So here, here, and here. So this first one is not, but the other ones, these lines I drew here, they all have, there can always be 3 points selected from them that are on the same line, like these 3 or these 3. Similarly, on this side. Yeah, not drawing very beautifully here, but you get the idea. So there are like for this one, it has 3 points. This one has 4. This one has 5. This one has 3 points, 4 points, 5 points, 4 points, 3 points, 3 points, 4 points, 5 points, 4 points, 3 points. I mean, like how many points there are on the line that it passes through. So there are, in the second choice, there should be 3 choose 2 times, yeah, let me change them to another color so that they are clearer to see. So how many, there are 1, 2, 3, 4. 4 of those will have, who is like 3 choose 2, sorry, 3 choose 3. And also 4 of them who is 4 choose 3. And then there is 2 of them who is 5 choose 3. And you add them up and you will get 40. Okay, I'm sure everyone knows the choose, so a number choose another number notation now, so I will stop explaining about this. Okay, let me erase everything here. And now, is that all? No, let's continue checking. So we've checked this inclination, we've checked this inclination. What if it inclines a bit more? I mean, we didn't miss anything, right? Because if I have this point, then like this is the only way I can incline. But yeah, same here, it only has 2 points. But if I move it a little bit, here it has 3 points. Okay, let's find all of them here. So does this one. So does this one. And there are 4 different directions for this. Let me draw them out in different colors for you to see them clearly. So this is an inclination that is similar to the one before. It's basically like you have an 8 and you're choosing these 2 points. Okay, let me use gray for another one. So yeah, let's see what other are there. Okay, so this one, and this one here. And then finally, let's use red for the last ones. Sorry. Okay, so on each line I drew, there are 3 points, exactly 3 points. So if I choose that line, then it is those 3 points that I drew. How many lines did I draw? There are 4 colors. Each color, there are 3 points. Why is that 4 color and 3 on each? Because see, we are getting a line from a shape like this. We're selecting these 3 lines. So it's kind of basically getting how many these shapes there are. And in each shape like this, there are 2 of them, the 2 diagonals. So it depends on you, however you want to view this, but there are 12 of this. Okay, I will keep that this graph here for you to like see it clearly, because we don't really have anything else to do now. I just want to quickly prove why I'm not missing anything, because this is my first like this straight line. Then I incline it by a little. I calculated them in case 2. Then I incline it more. I calculated in case 3. If I continue to incline it, then for me to have 3 points, I would need another 3 grids here so that they will form 3 points here, here, and here. But I only have 5 grids. So that is not impossible. That is impossible. That is not possible. If I incline it a bit more, it is even less like even more impossible, because that would require 8 grids. And then the final one is just a flat, and that I can't have. So I've calculated them in the first case. So yeah, we just do 2,300 divide, minus 100 minus 40 minus 12. This gives me 2,148. So the answer to this question is B.